This is an example for the paired samples t-test. So first of all, we're going to open up the data file. So open, again, no data files. I have to click all files. Now I get all the files, and I'm going to take the paired samples exercise data file, double click, and it opens up. And now you see that we have only 10 cases, right? We have students, 1, 2, 3, 4, 5, 6, 7, 8, 10 students, and we have a ACT pre and ACT post. So an ACT before they took part in training and an ACT after they took part in training. And now we're going to go into Analyze, Compare Means, and the Paired SamplesT t-test. And it's paired because we're taking the same people twice. Right? ACT before intervention is our variable 1, and ACT score after intervention is our variable 2. And we're already good to go. Okay. And here in the output we get our answer here. Again, the get file, the code that shows where my data came from. And then the t-test paired samples, and the two variables are ACT pre with ACT post. They're paired. And then again, missing analysis, and the criteria is 95%. So this here is the syntax, the language the program uses to do this calculation. Now if you look at the means, right, we have for pair here, pair 0, this AC score before, 26.9, 10 people, standard deviation of 4.56, standard error of the mean of 1.44, the AC score after intervention, 22.60, and standard deviation of 5.08, and standard error of the mean of 1.61. And then an additional component in the paired samples is the correlation. Right? We calculate the correlation, the ACT before and the ACT after, and we see the correlation is around 0.20. So the correlation is how strong is the association between those two components, between those two variables. How similar are they to each other? And we'll talk more about correlations in the future. When you look at the pair difference, we see that the difference between the means is 4.30. So before it's 26.9, then it's 22.6. So difference is 4.30, and the standard deviation of the pair differences is 6.11, which is a standard error of the mean of 1.93. And we come over here, the t-value is 2.23 with a degree of freedom of 9. Why 9? Just because we have one group. 10 minus 1 is one group, so 9. And this is, if we test it for a two-tailed significance, if we had a non-directional hypothesis, what would we conclude? At 0.05. 0.05 is still not smaller than 0.05. Only, right? So we still would not accept the alternative, would still retain the null. So we'd still say this is not a significant result. Very close, about as close as you can get, but we would still retain the null and say that there's no difference before and after. So this was the paired samples t-test.